In this tutorial, I'm going to show you the proof for the derivative of x cubed. First, I'm going to show you the graph of x cubed, then all the algebra. Let me plot x cubed now. I'll put in the x-axis and the y-axis, and the graph of x cubed looks like this. I'll put in a point and call it x, and the associated y value is x cubed. I'm just using f of x and x cubed. The y value is x cubed and the x value is x. If I add h to x, I have a new point, which is x plus h. And the associated y value is x plus h cubed. If I want to calculate the slope between these 2 points of x cubed, I can estimate it using a straight line. But I get some error. So what I do is, what I pretend to do, is I let h get smaller and smaller. I let h approach 0. So as you see, as these 2 points get closer and closer together, and I draw in a straight line, the error rate, the red area, is smaller and smaller. I'm letting h get really, really small, close to 0. As these points get closer and closer to 0, where the distance between them is almost 0, but not 0, I can create a tangent line. And that's one of the basic ideas behind calculus. Let me put everything back to where it was in the beginning. Again, the distance between the 2 points on the x-axis is h. I draw back in my line, and I'm going to calculate the slope of this line. And remember, slope is rise over run. The rise is this first distance here along the y-axis, and the run is the distance along the x-axis right there. You probably remember it being written like this in your algebra classes. Let me put these lines back. There. So the rise is x plus h cubed minus x cubed. And the run is x plus h minus x. In a moment, I'm going to show you that the denominator is h, but I'm going to leave it like this for now. So let me move this up a little bit to give myself some space. X plus h cubed I can write as x plus h times x plus h times x plus h. And then I'll subtract x cubed divided by, those two x's cancel out, just h. If I multiply x plus h times x plus h, I get x squared plus 2xh plus h squared. Now I'll multiply this times x plus h, and I'll subtract off again x cubed, divided by h. If I multiply these two together, I get x cubed plus 3x squared h plus 3xh squared plus h cubed. That's hard to say. Now I subtract off x cubed. Notice that this x cubed and this x cubed cancel each other out. Well, this divided by h. Notice there's an h in each one of these remaining terms. I'm going to factor that h out. Pull an h out, and it leaves me with 3x squared plus 3xh plus h squared divided by h. Like that. These two h's cancel. I am left with 3x squared plus 3xh plus h squared, and we're almost to the end. Now I'm going to write the limit as h goes to 0. I can put 0 in for my h's, like this and this, and I can scratch those off, right like that. This leaves me 3x squared, like that. Now I will use the power rule to prove that my answer, or to check my answer. So I have the derivative of x cubed is equal to x cubed. Take that 3 and move it down and multiply it in the front. Subtract 1 is equal to 3x squared. And by George, I have it. Bob Schunkel. Share the knowledge, share the love. Facebook, Google+, and Twitter. Like me. Like the videos. More proofs below. Subscribe, please. Help me. Please help me.